Hey dudes, Dude Builder here, and in this episode of Zig in Depth, we're going to be taking a look at how you can set up a brand new Zig project. There are two types of projects that you can set up with Zig, and this is something that you'll see often in the systems programming area. You can make an executable, or you can make a library. And this is pretty much coming from the C programming language tradition, where you can have executable programs that make use of libraries, actually the functions provided by libraries, and these libraries can be of a static or a dynamic nature. We're going to see that further on in the course, more specific videos further on. But for now, we're just going to see how to set up a Zig project and take a look at that structure that a normal Zig project has. Okay, so I have a empty directory here. Actually, it's not empty. It has a couple of sample files we're going to be using. But when you want to create a brand new Zig project, you want to create an empty directory for it first. So let's, in typical fashion, let's make a brand new folder called hello. Okay, and we're going to be starting off with the example of a executable binary project. Okay, so let's change to that directory, and to create the project structure, there's a command, actually a subcommand of the Zig toolchain. The Zig toolchain, basically the entry point is the Zig command. Okay, we already saw Zig version, for example. Okay, and if you just type Zig, you're going to get a pretty extensive description of all the options that you can use with the Zig toolchain. But to create a brand new project, there's a subcommand called zig init exe. This initializes the folder that we are currently in as a executable Zig project. There's also zig init lib, which will initialize it as a library project. Okay, but to start out, let's make an executable. Okay, and now let's clear the screen. You're going to see that this creates a build.zig file and an src folder. Okay, all your source code in a Zig project, you're going to want to put it in the src folder. Okay, the build.zig file is where the build system will find all the information it needs to build your project. And when we say build, we mean compile and whatever else you want it to do. The Zig build system is one of the most important parts of Zig, in that it uses the Zig programming language itself as the tool for you to control how your projects are built and anything else needed, handling dependencies and things like that. So you don't have to learn another language, another build system. Like in the case of C or C++, you have to learn Make, AutoTools, Ninja, CMake, a whole bunch of things. In Zig, it's just Zig. There's also no preprocessor to learn, separate macro languages or things like that. It's all Zig. Okay, so that knowledge that you gain up front, it's gonna pay off in a lot of things, including how you control the building of your projects. Okay, and this applies to C projects or C++ because you can use Zig to build those projects too. Okay, so let's just take a look at that build.zig. Since we haven't covered the Zig language, we're just starting out. This is gonna look strange to people not familiar with the language, but we just want to take a little look over the top. This is a heavily commented file, which will guide you pretty much to the different things that we can find here. But basically, the important details that we have to note is that this is just Zig. Okay, the build system uses this build.zig file which is implemented in the Zig programming language itself. Okay, so here's where we are defining, basically, since this is an executable type project, here we're adding an executable. Okay, and we're telling it that the root source file for this executable project is in src main.zig. Okay, so the build system will let you do pretty much whatever you want in terms of defining how you want to build your project. And here we're defining a run step, okay, which basically means that when you use the build system, you can define different steps that you can execute using the build subcommand of the toolchain. Okay, so here you can see we're defining a test subcommand here, which will allow us to run the tests, the unit tests, and we give it a name and we give it a description, pretty much like we can do in other build systems for other programming languages. But the difference is that this is all done using the Zig programming language itself. Okay, so let's exit out of there, and now we can do a Zig build. Okay, the build subcommand is pretty much the entry point to that build system. What build will do is pretty much read that build.zig file and do whatever you put in there. And in the case of this default executable setup, it will compile an executable. So let's do that. Okay, now if we do an ls, we're going to see that apart from the build.zig and the src that we had at the beginning, we now have a zig-cache and zig-out. Okay, the cache directory is exactly that. It's a cache of build artifacts and packages that may be needed as dependencies. We're going to be seeing that in the future. We talk about dependencies, and this allows the building process to speed up if there are artifacts and things that don't have to be rebuilt. They haven't changed. Well, they just get used right here from the cache. Okay, so for example, if I run the zig build command again, you'll see it's practically instantaneous because nothing changed. Okay, in the zig-out, let's do an ls of zig-out. You'll see there's a bin directory, and if we do an ls of that bin directory, there's our hello executable. Okay, so we can run it right now. Let's do zig-out bin hello, and that's pretty much the output that default executable prepared by init.exe produces. We're going to be taking a look at the source code to see how it does that in a moment, but there's a convenience command here, a subcommand. You can do zig build run, and it'll build it and it'll run it just like if those manual steps we just did. Okay, so let's take a look at that main.zig file, which is the only file right now that we have in src. Let's do an ls of src so you can see that it's the only zig file. Traditionally, this first entry point is called main.zig. It doesn't have to be called main.zig, but it's like a convention, which is pretty common in many programming languages. Let's take a look at that file. Once again, this is a heavily commented file, which will pretty much guide you when you're starting out with some pretty important initial concepts about the language. Here it tells you how to print to stud error. Okay, this is something that you're going to be using quite a lot, the stud debug print. Okay, here this is an import. We'll be learning about all that in future videos. Basically an import for the standard library. This is something that you're going to pretty much find in most, if not all, Zig files. It gives you access to the Zig standard library. With stub debug print, you can quickly print to the console. It does so in standard error, to the standard error stream. and it's really good for debugging and just printing out when you're developing. And since it's meant for debugging, it doesn't produce an error, so you don't have to do any error handling. Okay, when you really want to do the production output from your program, print to the standard output, you're going to do it this way. Okay, here we're getting the standard output file descriptor, and specifically the writer. That's a concept we're going to be seeing in Zig. And we're also creating a buffered writer, which is important when you're dealing with writing to files, and that type of I/O buffering can really enhance the performance of your programs. Okay, so this is an example right here of how to do a buffered writer with the standard output. Okay, and then you see how you can print, which is pretty similar to how you can do it over here with the stud debug print, but in this case you're going to see that we have here the try keyword, which means that this function call can fail. It can produce an error. If all of this seems really strange to you, well, don't worry, we're going to cover all these concepts in this course. And down here we have a sample of how you can do a test in Zig. Okay, a test in Zig, it's really a really integral part of the language. Really easy to include tests in your source code, which is a really good thing because you can put the tests close to the code that it's testing. Okay, and here we have a little sample, which is making use of a data structure from the standard library called an array list. It's pretty much a data structure that uses an allocator to grow as needed. And we have an example of using such a structure with the testing allocator, and an example of using defer to clean up the memory that structure needs. And here we add an item and we test. Okay, so as we saw, if we do the zig build run, that's the output, and it's telling us that we can do zig build test, which is the subcommand that we saw in the build.zig file that is defined in build.zig to run our tests. Okay, and let's go back to that main.zig, and it says here if we comment out this line, let's save that change, and we run zig build test again, we get this error report, which is basically telling us that we have a memory leak in our program. Okay, right here we see it's telling us that memory address have leaked. When you get this type of error, you're going to want to look for the file that you're actually testing. Here you see that these are files from the Zig source code itself. Here it's an array list. Okay, so we keep on going, still in array list, and here we finally get to hello src main.zig. Okay, and this is going to tell us where that memory is being allocated here, what we call list.append, and that memory is never being freed, and that's why it's telling us that there was a memory leak. Okay, so if we go back to the main.zig and we uncomment this line, which is the line that pretty much frees the memory, and run the still big test, now everything's okay. When we don't get any output, that means that the tests are passing. If you do want like a summary, you can do -s summary all, and that'll give you pretty much a summary of what's going on when you run any of the build subcommands. Okay, we can do that also, for example, with run. Okay, or with just the zig build, you can also see that summary. Okay, so this is pretty much how a zig executable project looks like. If you're going to be using Git, I will recommend to use, let me copy, I have a sample.git ignore, whoops, and I have a sample.get attributes. Let's take a look at that. Git ignore get attributes. Okay. Now git ignore, you're going to want to ignore anything that's in a folder called zig-anything else. Well, zig-star, which is a wildcard. This will ignore the zig-cache and zig-out because you're not going to want to put that in version control. And in the case of the git attributes file, this is very important when you're dealing with source code that you're going to be handling across platforms, specifically with Windows, because Windows will mess up your source code in terms of the line endings. Windows still, many cases, wants to use the carriage return line feed line endings, while pretty much everything else uses just line feed. So this git attributes file will tell Git to not do that for your source code, even though you're working on Windows. Okay. So that's pretty important to have those files if you're going to be working with Zig and with Git. Now let's move up. Let's make another directory called hello lib. Let's change to there. Let's clear the screen. And let's do a zig init lib. Okay. Now let's look at that build.zig. You're going to see that instead of, as we saw in the other example, instead of adding an executable, now it's adding, it says here, add static library. These are concepts that are coming from the world of C, basically. A static library will provide functions and data structures that can be linked statically, which means that they will be included in your final executable. Or you can also make a dynamic library or shared library, like it's known in the Linux world, which can be loaded dynamically while a program is running. Okay, and that's a really powerful concept. We'll be looking at that in another video in the series. So this is basically the build.zig that you're going to get when you do an init lib. Okay, here once again we have the tests. Now since this is a library, if I try to do a zig build run, it will build the library, but it'll give me this error message because there's nothing to run. This isn't, it's not an executable. Let's look at that main.zig, and as you can see, there is no main function here because it's not an executable. We do have a simple little add function here as an example, and it's using the export keyword, which means that this can be used from a program that uses the C ABI. So for example, you can use this from C programs too, but we'll be looking at that in future videos. Okay, so and here a simple test that tests that function. Okay, so this is pretty much what you're going to be doing in libraries. You're just going to be providing functions that can be linked externally, or functions that can be used from pure Zig code. We're going to see that also in the future. And you're going to have tests that test the functionality of those functions. Okay, and you don't need a main function because you're not providing an executable. You could provide executables, maybe to do like some benchmarking or something like that, and all that you can specify it in the build.zig file. Okay, so let's go out here. Now we ran the zig build, you can see, and if we look in zig out, we're going to see that now instead of a bin folder we have a lib folder. Okay, so let's look what's there, and we have the lib hello lib.a, okay, which is the convention for static libraries and basically in the world of Unix-like systems. And we'll be looking at that in future videos, how you can make use of static or dynamic libraries. But this is pretty much what I wanted to cover up till here. We saw how to create an executable project in Zig, how to create a library project in Zig, and pretty much the structure that those projects will have Mainly you have the build.zig, the source directory where you put your source code, and when you build, you're going to have your cache and your zig-out. Okay. There's also, let's copy. I have a sample here. Let's copy it to build.zig.zon, and let's take a look at that file. This zon file, which could be the zig object notation, similar to JSON, is used by the build system when you make use of dependencies. Okay, we'll be looking at that in future videos. And here you basically define the name of your project, the version. This is if somebody else is going to use your project as a dependency. And here you define the dependencies that your project is going to be using. Okay, and this is an example here of a library that I made to handle Unicode text processing. It's called ziglif. And basically you give it the URL and the hash. But we'll be looking at that in detail in further videos when we talk about dependencies. But I just wanted to give you a look because for completeness, we want to have that complete project structure. Well, this is basically what you're going to have. You're going to have your build.zig, you're going to have your build.zig.zon, your SRC for your source code, and the cache and the out folders, which are not included in version control when you use the proper git ignore. Okay, so this is going to be it for this one. This is Dude the Builder here. I'll see you in the next one.